like that, that you already have that knowledge, that theoretical knowledge. So when you prepare for the exam, or if you have a look at the slides again, then it's probably good to have them in the order, to have a look at the slides in the order that they are now, like processes first and then HDDs and SSDs. Okay, but don't worry. This doesn't affect anything. That doesn't affect the exam or what you've learned so far. It's just a renumbering process, actually. Okay, that being said, you may remember Bloom's taxonomy. I talked about it in the past briefly. So this is the general taxonomy. It defines learning goals, and in this lecture or after this lecture, you should be able to remember some stuff. You should be able to list the main phases of digital forensic investigation. You should be able to describe each phase in your own words, so it's an understanding goal. For apply, you should be able to apply some rules for evidence preservation documentation in an example case. Maybe this will be part of an exercise in the future. You should be able to write a forensic report for, given an example. You should be able to examine each phase of the digital forensic process and assess potential challenges. And the challenges part is key here. And you should be able to judge the quality of a given forensic example report. Maybe this will also be part of an exam in the future, but I don't know yet. So this is what you should take away from this lecture today. And let's start with the digital forensics process. So there is something that is called the investigative process model. It was developed by Owen Casey. We heard about him a couple of times so far. And the model focuses on securing digital evidence to be used in a court proceeding. And it generally models the procedure, or it's a general procedure model for digital investigations, and therefore it also includes police tasks. So it's not only for digital forensics experts, but also for police people. Especially in the US and in the UK, it's a de facto standard. In Germany, I'm not quite sure actually, but so in English-speaking countries, it's a de facto standard. The model is divided into 12 phases, and it's visualized as a staircase. And now we will have a look at the model and each phase of it. Okay, so here you can see the staircase, the investigative process model staircase. You can see the 12 phases. You can see that it starts here at the bottom and goes up. That doesn't mean that it's getting more complicated. It's just the order of steps, the sequence of events. And this part in the middle, the technical part, which is especially interesting for us, but we will talk about every step quickly. And I think you will get why while we talk about it. Okay, so the investigative process starts with an incident alert or an accusation. So incident alert could be that a company recognized that they were attacked. An accusation could be, oh, look, somebody stole something at the local supermarket. And that's the starting signal for the investigation and later the trial. And the first thing what is usually done is an assessment of the sources of the accusation. And so people, the police will ask, why did you think somebody stole something at the supermarket? reported the attack on the company, stuff like that. And we have initial encrypts here in this phase. So zu Deutsch, it would be Verdacht. So everything starts with the Verdacht. Okay, the second phase is the assessment of worth, in German Güterabwägung. There you try to decide if you want to pursue this further. This is especially interesting for companies or in a company context, where you can decide if you want to prosecute or if the costs for the prosecutions are too high. For the police, they cannot decide if they do something like that. They cannot decide if they investigate an incident. For example, if somebody stole something at a supermarket, they have to investigate. It's not possible to say, no, we don't do that. Okay, that's a difficult example. The company, the local supermarket could say, oh, you know what? It's not that expensive. This person is not allowed to enter the supermarket anymore. That's it. But for example, if somebody takes drugs on the streets, the police is not allowed actually to say, you know what, it was just a little bit. They have to investigate. For prosecution, it's different. So the prosecution, the Staatsanwalt, can decide if they pursue this, go further, or if they don't do it. Okay. So in this step, the involved parties decide either in favor of a prosecution. Pros could be a deterrent effect, compensation for damages, or the improvement of their own security, especially with companies. And the disadvantages of a prosecution could be the consumption of resources. Maybe if you are in a company context and you get attacked, you have to shut down your servers, then you have some downtime. Maybe you don't want that. Maybe you don't want a negative publicity. If you prosecute something, media will report about it, and maybe you don't want that for some reasons. And especially in the company context, almost always the companies decide against a prosecution because of the negative publicity, downtime, and the resources. And there are also some response strategies for companies where the organization in general decides how to deal with incidents of a certain class. And an example there for that would be the zero tolerance policy, where they say, okay, we go after every single thing that happens because of deterrent reasons. So every theft, for example, is reported to the police. But there are also other policies. Okay. So the next step on our staircase is the incident or crime scene protocol. What you usually want to do, so Tatortsicherung, in German Tatortsicherung. So what you usually want to do, or what would be ideal, is to cordon off the whole crime scene, like isolate everything. And Casey says, freeze the evidence in place and provide ground truth for all activities that follow. But the thing is, that's quite difficult, for example, for the internet. Of course, you can isolate areas in cases of malware to prevent further damage in the network, but also to the outside. You could shut down things if you get attacked by ransomware. But if you think about cybercrime, let's say scam over the internet, you cannot cordon off the crime scene. That's not possible. But yeah, that's That's the incident crime scene protocol or Tatortsicherung, and that's what you usually want to do, but with digital crimes, it's difficult. Okay, next step, identification or seizure, in German Beschlagnahme. In traditional or classical forensics, you bag, you vacuum, and you dust. So dusting means that you, for example, you have a surface and you have a fingerprint on it, then you dust it with this special something the criminal technicians use, and then you can see the fingerprint and use some special tape, get the fingerprint, and take it to the laboratory. So that's dusting. Vacuuming, we talked about that. That's for securing microscopic traces, and bagging is like you put the evidence inside an evidence bag. Okay, and of course you bag without changing anything. The surroundings at a crime scene can also be important. You should keep that in mind. Also for digital traces, for cases where digital traces are involved, the surrounding can be important. And this step of this staircase is the start of the chain of custody, and we will talk about the chain of custody later in this lecture. Okay. So next step, and this is where the digital forensics experts come into play. This is where the technical stuff starts. So preservation means that you ensure that the evidence remains unchanged. So we have, for example, we have identified an HDD at the crime scene. We now go over to preservation steps. So what we want to do with our HDD is we want to copy the data from the HDD, and while we're doing that, we want to ensure that the evidence remain unchanged. It also yields for classical traces. And at a crime scene or with classical traces, you usually photograph everything, you seal it, and you lock it away. You also do that with HDDs, for example. You copy them, you photograph every step, you seal them, and then you lock the original away. And that I already said. For digital evidence, create copies, further examination only on the copies. Cryptographic hashes are used to prove integrity later on. For example, if it's like, I don't know, the defense claims that something was changed, then you can prove the integrity of the digital evidence by using cryptographic hashes. And it's super important that you only use trustworthy tools to create the copies, but also to create cryptographic hashes and stuff. And as I said, this is where the work of the computer scientists and the forensic experts begins. So creating the copies can be difficult nowadays because of the amount of data you have to copy. And of course, you can work on the original if it's necessary, for example, in live investigations, but you should avoid it. And while the copies are created, or while during the preservation step, you should keep the volatility hierarchy in mind. So save data in order of decreasing volatility at a crime scene. And if it's done at a crime scene, of course, an expert must be on site because of the risk of data modification. Okay, next step, recovery. Recovery means that we want to recover data that has been deleted or hidden, disguised, or otherwise otherwise made inaccessible, for example, by encryption. And in order to do so sometimes it's just not possible. Then we have to accept that. But sometimes also synergies with other evidence can be used. If you think about encryption, then maybe there is some, I don't know, USB drive where somebody stored a file with all passwords, and then you can use that synergy to decrypt something else. Okay, but it can also be more technical. Yeah, but we will discuss that later. Okay, the next phase is the harvesting phase, where you organize large amounts of data. And for that, an initial analysis of metadata is performed. In that step, the actual data is not that important because it's mostly about grouping data by, for example, file type or according to access times. Yeah, you name it. Like there are several different yeah, types of metadata or other factors that you can use for grouping the data. Okay, and after that, the reduction phase comes into place. This is a phase where all the irrelevant data is eliminated. And for example, if we have a case that is about the possession of rhinography, illegal rhinography, then you could, for example, reduce the evidence to multimedia files. And but this is something that the police or the prosecution tells the forensic expert to do. This is not something that you just do because you think, okay, we don't need all the other stuff. Like this is something that forensic experts are told to do. Okay, and the goal is to have the smallest set of digital information that has the highest potential of containing data of probative value. Yeah, and reduction can also mean that if you already know that the case is about the possession of rhinography, and yeah, you don't want to, for reasons you don't want to go through every single picture on the device, then you could, for example, hash all pictures and compare them to a known hash database of known files. So what is done in cases of, for example, child pornography is that if you have a case with pictures like that, you hash them, and then the police or prosecution feeds them into a special database, not the picture itself, but the hash of the picture. And in future cases, you can compare your hash with the hashes from the database, and then you know already, okay, this is a child pornography picture. You don't have to have a look at it. You don't have to investigate it further because everything that is known about this picture is already there. Okay, was that understandable, the hash database thing? Okay, if nobody says no, then I continue. Yeah, exactly. Basically a lookup database, but for illegal material. So in child pornography cases, you also oftentimes want to yeah, help the people that are involved in this case, in the picture. But if you have them in the special database, you already know, for example, that the picture is old, the people were already helped. Yeah, you basically don't have to do more than just to just say, okay, it's illegal. Check, illegal. Okay, but that does mean if there are small changes to the picture, these databases won't help. Good question or good observation. There is something, how is it called again? Like there are special hashes that don't change if the picture only changes a little, and there's a term for that I cannot think of right now. I have to look it up again, how it's been called. Yeah, but there are solutions to that, like special hash values. Okay. Give me a second. Okay, so next step is the organization and search. So after the so Roman suggests chunk-based hashing, but that's not the term I'm looking for. I will look for the term after the lecture. Maybe it comes to my mind later. Okay. So in the organization and search phase, I mean, the name already is it's quite obvious what we do in that phase. You organize the data after reduction. You often create indices for faster searching processes and overviews. Sometimes search masks are already prepared, and yeah, this step actually it's just there to make everything that comes after easier. Okay, next step is analysis. And by analysis, we mean here investigative analysis. So when we talk about analysis in digital forensics, we often talk about preservation, recovering, harvesting, reduction, organization, and search. This analysis step in this investigative process model is an investigative analysis, not a technical one. So it's not about interpretation of data in a technical sense, but giving it a meaning, like a meaning for the case. So establish connections, determine who is responsible, evaluate the content and the context in terms of means, motivation, opportunity. Merge and correlate traces, and this step can be is usually a nonlinear and time-consuming process. What does that mean? So in this process, investigators ask the forensic experts again, like, for example, what does that trace in a technical sense mean? How is it created? Can you give me more information about that? Then you might go back down to preservation again, or might go back down to harvesting again to search for more data. Then you analyze again, then you find out, okay, there is something missing, then you go back to recovery. Yeah, so this can be a process that circles around here, but also could circle back to one of the phases before. And in this phase, the investigators and forensic experts usually work together, but still, it's not an investigative analysis. It's an investigative analysis, not a technical one, but they are still in contact. Yeah, especially if the case or the devices are very complex, so investigators need some help understanding what certain traces mean. Okay, so next phase is reporting. In the reporting phase, the results are presented, and not only the results, also how the results were determined. You also report on, or in this phase, people also report on the rules and standards that were applied. For example, you could say, okay, we applied the investigative process model by Casey. or you could say we stick to some ISO norm. And in the report, people also justify their conclusions. And reporting means forensic experts write reports about their work, about what they did in their technical analysis. But of course, also the other parties report on how they investigated the case. But for us, it means present your analysis results, present how you, for example, analyzed a certain trace, how you created your copies, the copies of your evidence, as I said, which rules and standards did you apply, justify conclusions. For example, if you say something like, okay, that timestamp means that the file was created before another file, then you have to justify your conclusion there. And of course, also alternative explanatory models have to be discussed. Like, for example, this trace could also mean that malware was involved and the suspect actually didn't download the file, something like that. Okay, and the last step is the persuasion and testimony. This is where the forensic expert is questioned before court. And if the forensic expert is questioned before court, then the person is called an expert witness. And the important point here is credibility, trustworthiness, reliability. And the challenge here is to communicate the right the important results correctly and in a way that everybody understands what you mean. And the basis for that is good documentation. So the problems are that the audience is usually without a technical expertise. So judges, prosecution people, defense people, they are lawyers. They usually don't have technical expertise. So you have to tell them what you found out, what you found in the evidence technically, but in a way that they understand what you did and what was happening. And often enough, especially lawyers use inaccurate or problematic analogies. For example, there was one case where it was a cybercrime attack on, I don't know anymore, systems, people. And the defense said something like, okay, going to the internet, surfing in the internet without having a firewall installed is like driving a car without the front window. And the defense person tried to make the point here that you are like, it's not only the fault of the suspect that the suspect attacked people, but they prevented themselves so badly that the suspect actually isn't guilty because like how can you be so stupid to go in the internet and surf in the internet without having a firewall installed? You wouldn't drive a car without a front window. That was the point that the person was trying to make, but the analogy is super incorrect and super problematic. So you have to be prepared for these analogies, and you should not do it yourself. Like if you try to make a point or explain what you did, you should not use these analogies because it doesn't work like that. And the expert witness also needs to be prepared for the cross-examination. So you also have to respond to the questions from the other side. So if you work for the prosecution, for the judge, or the defense, you always have to prepare for the questions from the other party. And expert witnesses are asked to help secure, analyze, and interpret digital evidence, make informed and helpful statements. And these models and also other models create a formal framework so that nothing is forgotten. So in your work, but also in your documentation. Okay, there are two questions. Document applied rules, do you mean as per established court standards, legal means to investigate evidence? No. So what I mean there is that you document your technical forensical rules, the forensical standards, the standards that apply to your work that you used for working on the evidence. The legal means, often enough, you cannot say much about legal means because we are technicians, forensic experts are technicians or scientists, computer scientists, but not lawyers. So we often are unable to say anything about legal means. And we will talk about that also later, but you got told what to do in a legal sense, so you don't come up with that by yourself. Okay, the other question is on reduction and small changes to known pictures. Could one also use the entropy of a file as sort of a fingerprint similarity measure, at least roughly? I think that's difficult because the entropy is not unique and hashes are unique. But you can use the entropy, for example, to search for certain files. For example, malware usually has a high entropy, or JPEGs usually have a high entropy. Encrypted stuff has a high entropy. But for fingerprinting, it's not really useful, I would say. Okay, people still try to help me with the term fuzzy hashing. It's not fuzzy hashing. It's also not Hamming distance. Guys, I will look it up later. Don't worry too much about it. Okay. So let's continue. So since the investigative process model is quite big and quite complex, not only I, but also other people try to come up with more simplified models. And here on the slide, you can see one. It's a simplified digital forensics process model based on Casey, but also BSI Leitfaden, stuff from Dewald and Freiling. So what you can see here that it focuses on the technical part, so the digital forensics expert part, and you have an identification phase here, which is the crime scene stuff, like, oh, that is an HDD, I'll take that. This can be something you have to revisit. Then the preservation, where you make the copies, that can be something that you have to revisit in cases you go back to the crime scene, find something else, and you have to do the preservation again. Or maybe your copy gets lost, then you have to copy the evidence again. The analysis part, and that one is a technical analysis part here, is something you might have to revisit again. Then you have the forensic expert reporting phase and the expert witness phase. And in the middle, the documentation, because you have to document basically every single step of this simplified model. So this does not include police work. It's more for digital forensics experts. And for the rest of this lecture, we will stick to that phases. So identification we don't do today, but we will now start with details on preservation. Okay, so preservation basically means forensic data access. And since digital traces are created via hard and software, they can also only be secured and analyzed with the help of hard and software. And for that, we can use forensic hard and software tools, but or forensic hard and software tools usually means that they do their task in a forensically sound manner. Forensically sound means they don't change stuff, they are tested. Okay, so rule number 1 for the forensic data access, for example, to create a copy of the evidence is don't change anything, as with classical forensics. But more precisely, it means change as little as possible and document any changes, because sometimes it's just not possible to preserve something, to access something without changing anything. For example, in live forensics, it's actually not possible. For data analysis, it's quite doable. But also, if you think about classical forensics, entering the crime scene already changes stuff at the crime scene because you exit it. But that's okay as long as you document any changes you recognize. Actually, there are also changes that you might not recognize. For example, if you think back about SSDs, we established that with SSDs, it can happen that single bits change because they lose their voltage, their charge, and maybe because of wear out or maybe because of other reasons. And then you have a change on your SSD that you not even recognized. So things can happen, but while you observe them happen, you should document them. And one thing that can help prevent changing the data, at least for that analysis, is hardware write blockers. So here you can see 2 devices. This is a simple or simpler device, simpler hardware write blocker. This is a more sophisticated one. What hardware write blockers do is they suppress write commands. Sometimes if you want to access like special areas like the HPA or DCO, then you need short-term writing access. This is not supported by every write blocker, but if you need that, there are hardware write blockers that support that. And here you can see that you connect your hardware device, your storage device, your HDD with the device. And then you can use the UI for interacting with the device. In case of that sophisticated hardware write blocker, you can not only copy the data, it also creates the hash value for you. That this device also does that, but that one you can also already decide what to copy. Do you want to copy the whole device? Do you want to copy single files? You can safely explore the device without copying it. You can do lots of cool stuff with that one, but it's also very expensive. In case you don't have a hardware write blocker, you can also use software write blockers. They usually hook interrupts and then bend them to special handling routines. And as the hardware write blocker, they only allow harmless commands or non-writing commands, not changing commands, but they are not as effective as hardware write blockers. And keep in mind that read-only mount is actually not a software write blocker, because read-only can still cause changes like changes in journal files, or fixing stuff in the file system that is broken, fixing boot sectors, fixing whatever structures, fixing partition structures, or causing timestamps to change. So read-only mount is not a software write blocker method. Okay, and be also aware of auto mounting. So if you want to analyze a copy, an image, a device, you connect it to your hardware, then make sure that it's not auto mounted. Okay. So as I said, documenting is a very important step. So you have to document everything. You have to also document the integrity of the copies you just created. As I said, we can use cryptographic hash functions to do that. And integrity means that you don't change data, and unaltered data means unchanged meaning. So these things go hand in hand. And what is a cryptographic hash? Actually, a cryptographic hash is a function that maps a long sequence of bits to a larger number. So that is our function, that is our bits, and the function maps the bit sequence to some kind of number. And using that for integrity checking works because the function has certain properties. For example, it is practically impossible to find a bit sequence M for a given V, for which the cryptographic hash function generates. Give me a second. Okay, it's okay. This one means that it is practically impossible, but I think it's not very clear written here. But it says that it's impossible to generate the bit sequence if you have the hash value. So you cannot revert the function. So the function takes a bit sequence, generates a number, but if you have the number, you cannot generate the bit sequence. Yeah, maybe I have to rephrase that. That's not very clear here, I think. Okay, and the second property is that you will not be able to find another bit sequence that generates the same hash value. So that's uniqueness. And this means that it's not revertible. So these two properties lead to the fact that we can use cryptographic hash values to check for integrity. Okay, so conclusion, it is practically impossible to manipulate an image undetected if the hash value cannot be manipulated. Okay, so 2 questions in the chat. What is the problem with auto mounting? So as I said, auto mounting changes things like journal files, timestamps. Auto mounting also sometimes fixes bugs in your file system, for example, and you don't want that. You don't want to change the data. Okay, and the second one is, should it be practically infeasible? Yeah, tomatoes. Yeah, but yeah. Okay, so for hashes, so as I said, nowadays we have like big amounts of data, and what is usually done is you hash the whole, you create a copy for the whole storage device, and you also hash the whole storage device. But as we already talked about, if one single bit is changed, then the hash value also changes. And this is not the same thing as the hash table thing. So in the hash tables, you use these special hashes that are like more robust for little changes, but for images and the integrity check, you don't want that. You want to see if only a little bit changed of your image. So you don't use these robust hashes. You use the ones where even a single bit changes the hash value, because you want to see if stuff changed. And that can also happen because of aging of the data, or if you use special or specific storage technologies like SSDs. And if that happens, the whole chain of evidence could collapse. And the solution to that is to create individual hashes for data chunks, or for special files, for partitions, for databases, like create more hash values for more single individual parts. And by that, the loss of data, or the chain of evidence, doesn't collapse if one single thing, one single byte changes, because then you can say, okay, one single byte or bit changed in that specific file, or in that data chunk, in that partition. We don't use that anymore, for example, and but the other stuff is still okay. We can still use that. Okay, and the second rule for forensic data access is that you want to access as low as necessary and as high as possible. That one refers to levels of abstraction. And you want to go down as low as necessary, because every level of abstraction can also introduce loss, because the more abstraction you have, the more you have to interpret, and interpretation means interpretation can go wrong. So as low as necessary and as high as possible, because on the higher levels of abstraction, they are actually the things we are interested in. It will become clear, hopefully, with that picture here. So the lowest level of abstraction is the device itself. For example, in HDD, you have some data blocks here, an HPA and a DCO. And inside of that device, we have some partitions. On the partition level, that's the next level of abstraction. On one partition, or embedded in one partition, we have a file system. That's again a level of abstraction. Then we have some files here that can be interpreted, for example, as email, as database, as picture, as whatever. And every single abstraction layer has to, or introduces some kind of interpretation that is required. For every single abstraction layer, you have to interpret the data in order to get to the next abstraction level. Okay, let me check my notes quickly. Okay, so as I said, every single interpretation step or abstraction steps could introduce loss. So, and we are interested on the file level, for example. If we are interested in rhinography, then we are interested in some kind of multimedia files. And the multimedia file, we try to secure the multimedia file, but it's also important to know where the file comes from. Like this file lies in that file system, which lies in that partition, which is on that device. So therefore, when copying data, copy as deep as possible, so that you still have the interpretation verifiable, but actually we are interested in that one. Okay, that's a little bit confusing. So we are interested in that one, but you copy from that device, and you also need to know where that file lies. Yeah. But you don't actually need to copy the whole partition for copying that file. You can also just copy that file and the information that the file is embedded in the partition and that the partition is embedded in the hard drive disk and where it is located. Okay. And for the imaging process, there are several types of images that you can create. There is a physical copy, that is the 1-to-1 bit copy. You can do that complete, like duplicate everything from the device. You could copy partially, so only a specific partition or only a specific file. And you can also do logical copies where you only duplicate specific files in the metadata. So for that one, for the partial duplication, you copy the file, but you also document the whole abstraction hierarchy, like where's the file embedded in? So that's the partial imaging. So the standard procedure so far is to copy every sector of a disk. But as I said, with growing amounts of data, it's difficult to do that. So what is usually done, or what was done, is like read every disk block or read the original disk block by block and copy everything. And the idea with that partial imaging is to prevent you from like a very long copying process where you have lots of unusual data or data that you don't need, and also it prevents you from copying things that are actually not important for the case. That could also violate the privacy of the suspect. So maybe there are files on the device that are of private nature, but they are not important for the case, then you should actually not copy them. But if you copy the whole disk, of course you do that. With partial hashing, you can only copy what you actually need for the case, but you do that in a way where you also copy or secure all the information that you need to tell somebody else where the file actually was located. And this allows for a later checkup whether the contents are exactly the same on the original disk and whether they were interpreted correctly. So that's partial hashing. For a logical copy, just to clarify the difference, for the logical copy, you only copy the file and the metadata of the file. So you don't copy this hierarchy. So with logical copying, you cannot say where a file is located afterwards. And yeah. So the idea of selective imaging or partial imaging is that higher level data is embedded in lower level data, and the lower level data contains metadata about the higher level. So that's the abstraction hierarchy. And so examples are the file name and the file size of a file. That is, the file size is actually embedded, or the file name also, in the file system. So this is metadata embedded in a lower level of the file. There are some other examples. We don't have to go through every single one of them right now, but I think you get the idea of partial hashing, partial imaging. Okay. And Yeah, in the imaging process, you can also do several things. So the question is where to copy the data to, and you can copy into a raw image file. That is usually done for one by one copy. You can also, of course, compress the data to save space, but there are also special image files or embedded image files where checksums, hash values, timestamps, and comments can be embedded, and the metadata can also be stored in a separated file. And there are many proprietary formats, embedded imaging formats. It depends on what hard and software you use. Depends on the manufacturer of the forensic hard and software, which image file is used. There are also some open source data formats like AFF4, but I think in practice they are not really used. Okay, I'm much slower than I thought I would be today. So we have 15 minutes left. No, have we? We have half an hour left, right? Half an hour. Great. Give me a second. Okay, we managed to talk about the investigative process model and preservation phase. I don't know if I am able to finish all the slides today, but we'll see. Okay, let's go on to analysis phase. So in digital forensic analysis, or the forensic analysis phase, as I said before, it includes the recovery, harvesting, reduction, organization, and search phase. And this analysis phase is a technical interpretation, and the technical interpretation is always based on an investigative order the forensic experts gets from the prosecution, the court, or the defense. And the problem with that is, as we already know, lawyers are usually not technical, don't have any technical knowledge or not much technical knowledge. So the investigative orders are often very vague, actually too vague. And the solution is to reconciliate or communicate with law enforcement parties, authorities. And the thing with that is that solution is good and you should absolutely do it, but still they are non-technicians, so also the communication can be problematic. So imagine you are a forensic expert, you talk with some police person about what you should analyze, and the question is what things should you examine and how should you examine the evidence? And then you might ask the police person, what would you like? What do you need for your case? So scientists need to understand the objective of the investigation. And therefore, they need the context of the proceedings, the context of the discovery of the trace, which forensic legal question should be answered, what actually helps to solve the case. And then you might get an answer, what do you have? Because the police person is a non-technical person and doesn't know what you can do with your digital evidence. So the investigator needs to understand what types of evidence are there, what probabilities are there, that specific traces can be found, what are the significance of the traces that have been found, and are the traces suitable for answering the question. So they need to know what is there, and that's a communication problem, obviously. So maybe this process goes back and forth, like, what would you like? I don't know, what do you have? Yeah, I have many things, but what would you like? And yeah, so we need to be aware of these communication problems that could arise, and they arise because a technical person talks to a non-technical person. Maybe there is no overlapping knowledge, and that's a problem. So yeah. So both sides need to understand or try to understand what is necessary for the other side, how they communicate, what knowledge they have and what knowledge they don't have. And if it's possible, it helps, as I said, to regularly reconciliate and communicate with each other, have a joint formulation of precise research questions or assignments, tasks, and yeah, and all that stuff, which traces are relevant, what is helpful for the investigations must be refined and discussed together. Okay, let's talk about investigative orders very quickly. Here you have an example of a hypothetical criminal offense. The criminal offense is some article in the StGB, and it says that the distribution, acquisition, and possession of rhinographic material is not allowed. And anyone who keeps at least 3 files with rhinographic content in stock will be punished with a sentence of 3 months to 5 years in prison. And so the investigative order says you are given an Exhibit X, which is a hard drive disk, and you should analyze the criminal liability according to that paragraph. So, what questions arise here? Is that an investigative order you can work with? So, it's a question to you guys. Put it in a chat. What's wrong here? What are the problems here? Especially communication wise. So, I said investigative orders are often too vague. What's the problem here? Okay, we have one person in the chat who says, "Sir, this is Wendy's. I don't do law." That's not the problem here. Imagine you are a forensic expert giving this investigative order. Would you know what to do? Are you still there? Okay. People fell asleep. I'm sorry for that. Okay, I will tell you. So the question here is that with that investigative order, you cannot know, for example, what exactly is punishable here. So we know that the possession of rhinographic material is punishable, but what does that mean? What is rhinographic material? Is it naked rhinos? Is it rhinos that are not covered enough? Does the rhino need to be underaged? So, what is punishable rhinographic material here? The second thing is, what does in stock mean? So this is not about the image being on the hard disk. It's not about the mere existence. It's about knowingly possession. So in stock means you have to have the knowledge about the fact that you have rhinographic material on your device. Yeah, and actually, the investigative author says analyze their criminal liability. And this is something you, as a forensic expert, cannot do because you would make a legal judgment. And if you do that, this can be understood as deliberately exceeding your own competences or possible reasons for bias. Yeah. So, for example, the defense could say, yeah, you want to see my client convicted, so you said it's a criminal liability according to no. So several things are problematic here. So what about that example? Is it better? So now this example says the public prosecutor's office would like answer to the following questions. Are there any image files on the data carrier that are potentially of rhinographic nature? For how many of the images is there reason to believe that the defendant was aware of their existence? Is that better? Or do you still see problems? Okay, we cannot prove or refute the last question. For many of the images, is there reason to believe that the defendant was aware of their existence? Yeah, I mean it's again about knowingly possession. So who did it? Who put the pictures on the device? And yeah, for that you would need to know who was sitting in front of the computer. And this is something that we already learned. We cannot answer that question. You can say there are pictures on the device, and the pictures are in the user folder with the name of the defendant. Yeah, but you cannot say, I believe the defendant was aware of the pictures. Yeah. Okay, and we still have the problematic potentially rhinographic nature thing. So only the judge may actually apply the legal definition. Analysts can only identify potential images. Maybe you can say they show this and that, but we cannot say they are of rhinographic nature or something like that. We can, of course, compare them to hash databases or certain lists, but the rhinographic nature is still a problem here. Okay. Okay. Okay, let's go to the reporting phase then. Now that we talked about communication in the analysis phase. Obviously, or of course, we will talk about analysis in more detail in the upcoming lectures when we discuss technical stuff. So the technical analysis thing, the methods, the techniques that use, Roman already talked about it a little bit, but we will go deeply into the technical stuff in the upcoming lectures. But for today, it's only about communication while you do the analysis, to also understand the challenges of that phase. Okay, so there's a question in the chat. So what was the first question again? Okay. It's about the rhinographic nature. Yeah. Okay. yeah, sometimes you cannot be sure about the content of a file. This is why I said the best way of establishing if something is interesting for the case in terms of rhinographic nature, and we all know what rhinographic nature stands for, then the best way to establish that would be the hash databases. But of course, if the picture is not in the database, you have to establish it in some other way. And in practice, forensic experts often have a look at the pictures and somehow assess what is on the picture, what can you see in the picture, which in my opinion is not the job of a forensic expert, and should rather be done by a trained police person or somebody trained to also assess if somebody's underaged, or what can be seen on the picture. Is it relevant or not? Okay, let's talk about reporting. So reporting for forensic experts means that you have to write a forensic report, and the forensic report is aimed primarily at non-technicians because you use it before court to testify as an expert witness. So you testify based on your report. You bring your report. Everybody in the courtroom has your report, and based on that, you are asked questions and you testify. And so it's aimed primarily at non-technicians and secondary at technicians who should be able to verify your results. For example, I don't know, special force of police police persons should be able to verify your results if they have technical knowledge. And therefore, you have a non-technical summary at the beginning. Usually, you have that, and technical details afterward. So a good report must contain, obviously, the title and other basic information like who authored the report, date, case number, reference number, but also versioning. You should contain a prologue with the case context, like you should list the traces, and you should recap the investigative order, your working environment. This is especially important because maybe someone wants to repeat your analysis, and then the person have to know how your results where they come from. Like, how can we come to the same result? For that, we need the working environment. Then we have that non-technical summary, the technical summary, and then the details. And on the next slides, you can see an example forensic report from PsycPro. That was a consulting company for forensic investigations and IT security. The company doesn't exist anymore. I worked for them for a couple for some cases. I worked for PsycPro. They allowed me to use that example report in the lecture. It's not a real report, it's just a template, but still you can get the idea and the structure. And so as I said, we have a title here. We have something that says some information about the prosecution, about the case, about the person who wrote the report. We have the contents where you can see that there is, it's probably a little small, but you can see that there's the investigative order at the beginning, a summary of the results, the methods and environment summarized here in point 3, and then the actual analysis and some kind of conclusion. And the technical analysis could, for example, look like that. You have a picture here of the device. You also sometimes you assess the worth of the device. because it might be of importance, or the device might get destroyed during the analysis, and then you have to actually pay the money it was worth to the defendant or suspect. Yeah, okay, you can have a look at it also afterwards. It's on the slide. Yeah. Okay, so much about the report. The very interesting part, at least communication-wise, comes now. It's the presentation before court. As I said, if you testify as a forensic expert before court, then you are an expert witness. And expert witness, the court has to decide about some real-world case. So something has happened and the court wants to apply a legal norm to the case, and the court must find out what has happened and interpret the law. And the expert witness is a specialist in their respective area, appointed by the court to assist the court to understand what has happened and how, in a technical sense or in their respective area. And so I already said the expert witness is appointed by the court, but all involved parties can make suggestions on who to appoint. Like the defense, the prosecution, and the judge can all make suggestions on who to appoint, and then in best case they agree on one person or one company or one party, and this party is appointed expert witness in the case. And this is all what I talked about now, and what will come on the next slide is all that focuses all on German criminal court. Okay, if you are appointed an expert witness, you have to know that the rejection of appointment as an expert witness is not allowed in cases, or if you are, for example, a publicly appointed expert witness in the respective field. And publicly appointed expert witness means in German öffentlich vereidigte sachverständige Person. And you get the title from the IHK, the IHK, Industrie- und Handelskammer, and you have to do an exam there. I think you have to pay some money, and then you can become a publicly appointed expert witness. It doesn't, if you have the title, it doesn't mean that you are more qualified than others to do the job. It just means that you had this examination at IHK, and that you cannot reject appointments. You can also not reject the appointment if you publicly offer for profit your services in the respective fields. So consulting companies, if they are appointed by the court, they cannot reject that. So, for example, I told you that SidePro, the company that doesn't exist anymore, that I worked for them from time to time. And one time I worked for them because they were appointed by the judge as expert witness. They told the judge, "Oh, we have so many cases currently, we cannot do it." And the judge said, "I don't care, you do it." So they asked for help, basically, for more resources, and so I helped investigating that case. Okay, who else cannot reject the appointment? Anyone who is publicly appointed or authorized to practice a science, art, commerce, e.g., physicians professor at public universities. So again, I cannot reject the appointment as an expert witness because I work for a public university, and I'm practicing the digital forensic sciences. Okay. Another person that cannot reject the appointment is are persons or is a person that has agreed to act as an expert witness in the respective case. So if you once said, yes, I will do it, then you cannot come after 2 weeks and say, okay, I changed my mind, I don't do it. That's not possible. Okay, there are exceptions from that. There could be reasons that would allow a witness to refuse making a statement. For example, if you are close to a party involved in the crime. Expert witnesses can be rejected by the court or the prosecution or the defense if, for example, economic interests could be established. If the expert witness has personal or business relations with one of the parties, if the expert witness was previously involved in the case or has a one-sided involvement of one of the parties or to one of the parties, if the expert witness is emotional or makes emotional or unobjective statements, for example, I hate certain people, I hate hackers, I hate criminals, all of them should be put behind bars forever, then you could be rejected. And of course, also when you have unauthorized involvement. And if the expert witness themselves consider themselves as biased, this is not relevant for the court. You don't get rejected because you by yourself say, I think I'm biased. So the court decides on the rejection. Okay, as I said, the communication as an expert witness before court is similar to the report. That's because it is based on the report. We already talked about that the target audience is usually a non-technical one, and the expert witness should prepare themselves by thinking about the question that lawyers may ask. And that could, for example, be the questions we discuss on the next slides. But first, I also wanted you to know that speaking the language of the target audience is also important because it can be very difficult to simplify stuff and still sound like an expert. And you don't want to make yourself vulnerable. So this is also why you should not use like analogies and stuff like that. And try to balance this non-technical communication with and simplifying things with still talking like an expert and talking in a technical sense, because you don't want a party to say something like, oh, are you actually an expert, because you sound like a normal person basically. Okay, so prepare yourself for questions regarding certain phases. For example, in the preservation phase, you might get asked, was the electronic equipment correctly secured? So was the device, the evidence correctly secured? Was the bypassing of the access code correctly carried out? Was the data correctly safeguarded from complex infrastructures? Like the preservation phase, you can see here that it very much focuses on securing evidence from manipulation and changes and stuff like that. In the analysis phase, you might get asked what data concerning the crime can be found on what exhibit, what is the location of certain data and what does it mean, was the data accessible by the use of software available to the suspect. So these are just a couple of example questions so that you know what questions might get asked, what questions are interesting for the audience before court. Or you might get asked, how did the digital evidence end up on the material under examination? Does the read data match a scenario outlined in advance? Given the evidence that was found, what can you say about alternative hypothesis? That is super important. Even though you got an investigative order from maybe the prosecution, you still have to look out for data that supports another hypothesis. You are not there to convict people. You are there to neutrally, objectively have a look at the evidence and search for traces. Another question could be how much knowledge and skill in the field of digital technology is required in order to achieve a particular result. So that is a question of manipulation. So what skill would you need to manipulate certain data? Okay, so the last step or the last thing I want to talk about today is documentation. Rule number 3, document everything. And everything means like everything, every single step. Often the documentation starts with photographing the identification phase. We have the chain of custody, zu Deutsch Verwahrungskette. It includes the time, place, person carrying out the seizure, recording, transfer, analysis, and whereabouts of the trace. And in the case of digital traces, the documentation of the chain of custody usually refers to the physical trace carrier, so the support, and copies of digital traces also have a chain of custody where you document when it was created, the hash value, who had access to it. So in general, the chain of custody documents who had access, when somebody had access, times when nobody had access, where is the trace or the evidence, what status is it in, and it's a local and temporal progression documentation. Okay, how to document for digital traces. Sometimes people still say document everything by hand on paper because it's you can manipulate it. It's harder to manipulate. I will very briefly go over all of that stuff so that we can finish the process part today. So this is questionable, discussable. Some people still think it's better to document by hand. In any case, document every step. So, for example, as I already said, by photographing the identification phase. There's also the possibility to automatically document the analysis phase, for example, with script. But script has a couple of problems. For example, it also documents control characters and stuff like that. Then you have to filter the output at the end. And this is actually a manipulation of the documentation. So somebody came up with the idea of FORScript, so for forensic script or script for forensics. It's a little bit better than only script, but it's pretty old and also has some problems. So automatic documentation is currently still difficult, but you could also, for example, take a video of your analysis. You could take a screenshot. You could apply the 4i principle and do it together with a colleague. You could record the screen. You could record the monitor output. There are a couple of options how to document. Which one is best is, I think, it depends on who works on what. And the last very important step, and also the last slide, Yeah, so the last slide for today is the documentation of time, which is very important, very relevant. Keep in mind that you have two different times. So you have the time on the object of investigation and the time on the examination computer. And for that, for the object of investigation, the evidence, you want to know if the computer is in the correct time zone, for example, if NTP was enabled. Yeah, it's super important to know if the time is correct on the object of investigation, because you might draw wrong conclusions if you are not aware of, for example, the fact that the time was manipulated on the evidence. And for the examination computer, for the working environment, it's important to verify the correct time because of documentation reasons. Okay, so that's it for today. I will look up the hashing term and tell you about it next time, or put it somewhere in the announcements. And yeah, thank you for your attention. If you have questions, you can still ask them. But for everybody who needs to go, have a nice weekend, and see you next time. So I'm still around if you have some questions. I'm still there for a couple of minutes.